On behalf of IIT Madras, I want to welcome all of our guests to the campus. Journal of Fluid Mechanics, it's one of the most pleasant journals to read. I mean, there are different journals that you read and you have different impressions of them. But even when I was in graduate school, I remember going to library and I always found JFM among the most pleasurable to read. And to me, that's very important.
I thought this was an opportunity for us to get the graduate students in IIT Madras exposed to some top research work, so that would be a good motivation for them to aspire, publish, and in top quality journals.
Okay, so admittedly cats are not a good representation of attached eddies, so let's use something else. Let's do that same cartoon exercise again. So here I've got some sketches of things that normally look like eddies.
I like fluid dynamics because there is a lot of things that we don't know exactly. There is a lot of complex physics happening. We are not yet found what are the things that actually the real parameter for the fluid mechanics outcomes.
Now the theoretical description of this transition has been a very notorious problem in fluid mechanics. The basic reason is that when you do a linear stability calculation for Newtonian flow in tubes, it is now well established that the flow is always stable to infinitesimal perturbations at any Reynolds number.
My favorite fluid is water, and of course you can easily disturb the water like the nature does on the oceans, and we can do the same thing in our water tub. So that's the very fascination and the motivation for me to start a fluid mechanics.
So this is the marks in length. The flame stretch is essentially a measure of the deformation of the flame surface. So when the flame propagate out, when it's curved, it's being stretched.
Why I interest in fluid mechanics is because it is very close to nature. Wherever you see some flow of reverse flow of water on any surface, it's something to do with the fluid mechanics.
And you see that there is a peak associated with a region where you have high droplet concentration in the spray. That where you have high droplet concentration, you have a departure from the 1/3 matrix, meaning there is diameter lock-on.
I'm amazed by how basic science of fluids can do wonders in science.
You can free this ice shelf from protruding bedrock, and by doing that one reduces the buttressing force back onto the grounding line and the ice sheet behind it, and that is what's happening at Pine Island Glacier, for example, which is the region that is most rapidly thinning in Antarctica in the present day.
The thing that fascinates me, fascinates the most about fluid mechanics is that you see fluid flow in everyday life. It's something that happens day to day, that you see in your day-to-day life. So I'm very much interested in understanding the fundamentals and things like that.
So one can think of these equations are essentially governing the evolution of perturbations A and B along trajectories in the base flow. Right? These are a set of ordinary differential equations in time. Given with time, we assume that we are moving along some base flow trajectory.
And today's the seminar and lectures is going on. It's awesome lecture and thank you JFM for such opportunity at IIT Madras.